And welcome today, everyone, and thank you for joining us. We will be covering Applitools Execution Cloud and the magic of self-healing infrastructure for the next about 30, 45 minutes. We'll go over a couple slides quick, kind of walk you through the problem and really what teams are facing today with locator strategies. And then we'll go into a live demo with Matt. And we'll check out Applitools and running some tests on the Applitools Execution Cloud. All right, so really what we'll be looking at today is the makeup of a test, kind of what parts there are, the challenges with some of those parts, and really the locator strategy behind it. And then we'll look at really self-healing locators and the self-healing execution cloud with a live demo after. So no further ado. All right. Each test case has three main parts, and we'll be discussing really two of them today, but we like to think about it in three major sections. The first is test data, and that's the properties, objects, and the data that we're injecting into our actual flow. Again, maybe a form, maybe a piece of logic that something needs to be returned based off of, but it is kind of its own objective piece of the test. It's the first part, test data. The next portion is test interaction. And this is really the portion of clicking, navigating an application. It's actually traversing what a user might also interact with as we're testing the application. And again, this is the actual action steps we're taking throughout. It could be clicking things, it could be filling out information, it could be dragging items, but it's all those different pieces of interactivity throughout our test case. And lastly, there's the test assertion. So this is the portion that we're really worried about asserting and validating, again, that the output of our test is correct. A lot of times, we'll talk about today, teams rely on the interaction steps to kind of calm their nerves or assert that things are working. But we really want to break these things in half. And we'll talk about that a lot in the coming slides. So first, let's just walk through kind of a sample test case. We have it in English here, just so we can look at the different parts that are interaction, look at the different parts that might be validation. So we'll just go through the steps here quick. We'll visit a login page. We'll click the username field, and then we'll enter in our username. We'll click the password field, and then we'll enter in our password, and then we'll click a submit button, blue submit button, and we'll make sure that the dashboard URL loads. So we'll make sure that after I click submit, I'm able to go through that action and something works. So 85% of this test case is just literally simple interaction with the app. We're not actually asserting anything that needs to be done or should be there until the last step, right? Step 7 is really where we look at that assertion portion. But 85% of that before is really just the actions that we're taking through. But in order to do some of these actions, right, in order to click this blue sign-in button, we don't use the presentation layer of the application, but we use what's right behind that, and it's the DOM. We rely on the DOM to actually go and click that sign-in button. And you can see here from our test case, it's riddled with locators from the DOM, right? And we have ones for pressing the keys, ones for sending in our actual information. But it is a core piece of all open source testing. But locators have a lot of drawbacks. They're the primary cause for flaky tests, which we'll go through today, obviously. They're extremely high maintenance. These are the things that occur on the page that constantly change and are the 90% of where we spend our effort when we have to maintain tests. And lastly, really what we'll talk about a little bit today is it's an archaic way to select an element. We'll see with visual AI and Applitools, we can do these things in a different way. Yep. And again, test flakiness is coming from the problems with the interaction, right? It's not the verification phase. So when we have eyes and we offload that verification to our AI, that is solving a lot of maintenance problems. It's solving a lot of test creation problems, but the flakiness had not been solved. Flakiness still occurs. And that's because you can see right here, it's because that the locator can change on a whim. The small change from a dev team, from an ID, that correct ID to a wrong ID, that can completely derail an entire testing pipeline. And that's because testing tools see your application like a computer. They see the entire presentation layer as bits and pieces of code. It's HTML, it's CSS, JS. It's still interacting with that computer-led display, not the presentation layer that a user sees. And you can see here, version A, we have the sign in button. It's got a couple of different class names, XPath, ID names. It all builds this button that says sign in. Well, we can change this completely as a dev team with version B, change all the class names, change the ID names as they occur in the DOM, and nothing changes to the customer, right? There's no difference to an end user. Nothing that they interacted with has changed to them at all. Yet from a testing experience, we're still failing, right? We're now failing this test because of the development change that occurred on the piece of button. But the actual user experience is really what we're validating. Nothing changed on that side. And again, when we talk about like the archaic way that this is brought about, it's really the difference between the machine and the computer code behind it and the presentation layer that gets built after. And it's a core piece, I think, of the challenge between dev and test. You can see here a great quote from Mike Callahan. He's a tester at Disney. And when he talks to his test automation team, it's not really that they're having problems with a lot of testing parts. It's that the dev team is changing the back end of that presentation layer on them. So there's nothing static. Again, even though the DOM to the user doesn't change, there's nothing static for them to grab onto. And this is a huge challenge, not only for flakiness in pipelines and speed of pipelines, but also just in the collaboration that I think occurs between dev and test, right? This is always kind of this point of contention between these two teams. And the big solve here is, and what we'll talk about and what we'll show off is, Applitools with Visual AI is seeing your application exactly like your users, right? We're using AI to actually look at the visual nature and the presentation layer of your application. And we're using AI to take that snapshot. But we're also thinking about how we can use this on the interaction layer. And I think that's the big breakthrough that we've had with Applitools Execution Cloud. It's the first self-healing test infrastructure for open source frameworks, right? So this is something that has slowly been creeping out in tools that are proprietary codeless tools, but nothing has been built that has been able to scale for teams using open source frameworks like Selenium or WebDriver.io or any of these other OS-based tools. We're the first platform that you can run in the cloud that will self-heal the interaction portion. So you can run that for functional tests, but you can also run it for your visual eyes tests. So now you have one single unified execution space where you can run not only your functional tests that don't have eyes, but also your visual tests that are using eyes. So it's a great place to bring, again, all those results there and use the self-healing actual technology to run those tests. You'll be able to speed up your tests. So running on the Execution Cloud, because it's a new infrastructure, it's very modern. We built it in the last 2 years. We're able to launch and run your tests in the cloud at tremendous scale with speed that is much faster than traditional testing clouds. We run obviously a lot of regressions against our competitors, but we're really seeing at least a match speed or better for all of those testing runs. We also have advanced and more resilient tests, right? With the self-healing test locators, you'll see that not only can you ship faster, you won't have to maintain as many tests because of your UI changing, but also just the flakiness. Again, when you use poor locators, when you use maybe obfuscated UIs when you're trying to test them, the resilience of tests run on the Execution Cloud is an absolutely huge benefit. And lastly, you'll help improve coverage. Running on the Applitools Ultra-Fast Test Cloud with Eyes, Ultra-Fast Grid, and the Execution Cloud, all again, within one unified experience, you'll be able to rapidly improve coverage, not only on a single UI, across browsers, and also more scenarios as you're running your tests in parallel in faster speeds. So again, you can quickly integrate your open source tests. So Selenium, WebDriver-based tests right now with our Applitools SDK, and you can run those tests in parallel on cloud infrastructure, just like many competitors. But again, we're adding that ability to not only run Eyes seamlessly, run it faster, we're also self-healing the interaction portion of that test run itself. So let's finish up here and talk a little bit about how does self-healing work? What are we doing maybe behind the scenes, and what are we applying? Every time we find an element throughout your test, whether it works or whether it doesn't, we're capturing hundreds of data points about the element. We're understanding not only different locator strategies about that element, but also understanding the contextual space that it's in based on other elements and location on your page. We're storing all of that in a database, and then we're recalling that when elements can't be found, right? So when an element can't be found during a test run, we will then go call all of that contextual information. We'll run our algorithms and see whether our element can be found that is based inside a bounds box that we have that can complete that test. So can we find that button based on several other factors and still successfully complete the test? If it is successfully completed, we'll update the DB, our database, with that new information. Again, so we're constantly learning new information about what your test runs are interacting with, and then also the DOM and how we can improve the resilience of your tests based on that. So what can we heal when we're doing this? And this is something we'll go a little bit through Matt, and you'll see some live use cases, but we can find an element even if element properties change, right? So an ID or a tag name or a data ID, something in there, if it changes and other things stay the same, we'll still be able to pass that element. Let's say the text changes, right, on the button. This is something that we'll talk a little bit real quick about the philosophy of interaction versus verification. Text change on the button, if we need it to say exactly the words that we want it to say, that should be a point of our verification in the test, right? So we should drop a checkpoint in that piece. We should actually validate that the button says the words that we want it to say. But if the tester goes in, they use that text as a locator, and it changes, that's like a pretty flaky proposition, and that's something that happens constantly. So we feel that that should pass, and we'll apply our algorithms to make sure that that happens. Again, if you'd like to validate that the text remains the same, you can still do that with a checkpoint. But this is where we're really trying to decouple test interaction navigation with test validation and assertions. If the DOM position changes, right? So if it changes in the hierarchy and the order, if someone is using an XPath that has ordering and that changes, nothing may change to the end user. So there, we'll still pass that. And also size and locations. Again, if we want to assert based on that, we will drop an eyes checkpoint. If we don't want our flaky test to break on that, this is where self-healing comes in. And we'll also add implicit weights for elements, and we're really adaptive, again, to the UI changing as your development team either changes the underlying structure, or if they do add new elements to the UI, or they make presentation layer changes. So when is this useful, and when is it, I think, best or most benefiting testing teams? The first two are very similar, but following UI changes, being able to run the test through, and again, as long as you're asserting the end output and not the things, the middling steps, this is great. We can make constant changes to the UI and still run a test through, see if it passes, and not worry about maintaining that test. So when we're spending tons of time during test maintenance, this is going to drastically drop that effort. If your UI pages, if it has certain content that is frequently changing, or again, small button that may change, this is now a chance that we can use self-healing to rapidly go through, never worry about maintaining maybe that piece of the test that changes, but we can still assert the last output. Poor locator authoring strategies. This one is maybe a learning tester, a novice tester, or maybe they're unaware that they're selecting something that frequently changes or is about to change. Self-healing is great for kind of helping those testers out. And then the last two here are structurally changing with, I think, the modern web. A lot of apps have dynamic generated UIs, maybe UIs that have obfuscated CSS classes. All of these make picking selectors or using and requiring selectors to actually not be useful for web apps, websites that get compiled during runtime. So again, you can think about some of these new frameworks, Astro, Next, Gatsby. It's not always a one-to-one comparison between what the dev is using and their classes and what actually gets spit out in the DOM. So again, this is a great, useful benefit to using self-healing technology when we're testing these modern web apps. All right, so we walked through a little bit of slides and kind of set up the problem, and now, thankfully, we'll get to look at some real live use cases with Matt.
So as Dan mentioned, I have a couple of examples prepared for us today just to kind of show the power of self-healing and how it works. First, I just want to walk through the example that we're going to be going over. It's very similar to what Dan was discussing earlier in the presentation. We're navigating to a login form, entering in a username and password, and then clicking the login button, and then ultimately asserting that we navigated to the dashboard successfully. In terms of running the test on the Execution Cloud, there's really only two steps that you need to perform. The first is to call this API that gets an Execution Cloud URL, and then you pass that to the driver using the capabilities. And so that's pretty much it, and you're up and running on the Execution Cloud. So this is what the website looks like that we are going to be testing. It's just a simple login page, as Dan mentioned. We're going to be typing user and then password, and then signing in and validating that. So let's go ahead and run the first example and set up the baseline. All right, wrapping up. And we'll head over to our Applitools.
Is there anything more nerve-wracking than running live code examples, Matt?
Yeah, exactly. So, all right, so we got our baseline set up. We successfully captured a visual AI assertion of our dashboard, and now we can go back and run it again. So now let's simulate what might happen if a developer makes a change. So I'm going to add a query parameter here that's going to affect the page and kind of mimic what might happen if in a development cycle when an unexpected change occurs and messes with the selectors that are on our page. Now you might notice this capability right here. By default, self-healing is enabled every single time that you run on the Execution Cloud. So just to illustrate that our selectors are in fact broken, I'm going to run it without self-healing to see what your tests might look like when you're running the test without self-healing enabled. And as we can see, our test fails, our selector is no longer relevant, and there was a change to our page. So now, if we weren't if we weren't using self-healing, we'd have to go back into the code, talk to the developers, and understand what exactly is happening. Is there an error with our application, or is it, in this case, just something with the selectors breaking? So now let's turn self-healing back on and rerun the same exact test. And as we can see, we get the little check mark, which is a good sign, showing that our test did pass this time. And we're just waiting for the ultra-fast grid to render our visual AI assertion, and we get one passing test. So now, even though our selectors changed on us, wait for this to come in. Did it not come through? I think you cursed me, Dan, with the demo.
So run one more time. We'll see.
Let me try to run this again. Okay. And there we go. Okay, so as we can see, our test passed this time, even though we saw that the selector has changed and our test should not have passed. But we see on our Applitools dashboard that we now have this magic little icon that's showing what exactly happened and what selectors were broken and how they were automatically healed using the Applitools Execution Cloud. So you can see here the username, the password, login IDs were no longer relevant. So using the Applitools AI, we were able to heal the selector on the fly and ultimately let the test pass to completion without preventing our release from being obstructed. And so this is just a basic example showing what happens if like an ID or something like that changes. But another example that might be powerful is what happens if the actual structure of the page changes. So if we were to, for example, rearrange this form to kind of change the ordering of the elements on the page so that the sign-in button that we're clicking and the input forms over on the right are in a completely different part of the app. How would we be able to select those if we're using something like a XPath selector, for example? So in this other example here, instead of using a CSS selector, I'm selecting these elements using an XPath, which is directly relying on the order of the elements on the page. So let's run through this example as well and just run this test once to set up the baseline. And we'll go through a similar pattern here. We'll wait for this to wrap up, and we'll confirm that our baseline did in fact get created. And here we are back on the Applitools dashboard. We can see here we have another new test, this time for the changed form test. So now let's do the same thing, and let's toggle off self-healing for the time being, and then simulate the change that we have on our form and rearrange the form to be in a different layout and see what happens when we try to run this same test with those XPaths. So, as expected, this XPath no longer points to anything on the page that is relevant to us. We are unable to select the elements that we are interested in interacting with. But if we turn on self-healing, even with this change to the page where everything is in a completely different order and our XPath is very specific and targeting a very specific section of the page, the Applitools self-healing, and as we can see, we get the little check mark, which is a good sign. The Applitools self-healing is smart enough to even take something like a page restructuring and allow our test to complete to succession. And as we can see, same thing here. We get the little magic wand indicator. We can see this XPath is no longer relevant, and it shows us which selector the Applitools self-healing used to heal the test and ultimately let it pass. And that is pretty much it. So I will pass it back to you, Dan.
All right, amazing, Matt. I was just gonna, you can do that too. Can you open up your IDE and we can just look real quick?
Of course.
Yeah, as we go through some questions. But the first one from Stoyan is great one. It's a perfect kind of use case for this. So we're asking how Applitools handles kind of wrong tests and, again, the validation side. So previously used some self-healing technology. One of the tests was healing itself, and maybe an assertion was still passing after it healed. And I think that this is what we're talking about when we say we really want to separate interaction and validation, and then rely on the eyes check in between kind of maybe navigation steps to really make sure that everything is working properly. So for this example, we can't, when we're sending keys, let's say, or when we're clicking things, and there might be 4 things to click, we can drop in an eyes check in between those and make sure that along the way, we're still getting the right information, where the navigation, the interaction might underlyingly be changing and self-healing. So I think that's like where we really want to decouple those two practices. The second one here, waiting for elements to disappear. So yeah, let's say your Selenium test is looking for something, but it's supposed to appear and then not appear. Obviously, self-healing is going to try to fix that case. We do have an implied wait for it that should be able to get around this use case. It's definitely something, though, that we bring up to the team to make sure we're able to handle. I know we do have a couple of floating ones that we like run examples on, but this one is definitely a good one, Stoyan, and we'd love to look at it. So if you're able to run your tests, check it out, and let's see if that element moves. All right, another question around cross-browser testing. So does Execution Cloud have, what browsers does it run on? So I can take this one. Right now, Execution Cloud is running on a Chrome browser only. So it's running all of the interaction on that single Chrome browser. We run it in parallel, but again, we rely on the ultra-fast grid to run on cross-browser testing tests. So from an interaction standpoint, we find most browsers to have JavaScript rendering and obviously the basic blocks of HTML, all very similar. Where we see the biggest discrepancies is in CSS and presentation. And that's where, again, our philosophy is to run single-threaded interaction in parallel on a Chrome browser, and then use the ultra-fast grid as our cross-browser testing grid to speed up all of that test coverage. All right. Can I see a log my test? So they're video logs. Matt, you want to go over that one?
Yes. So on the dash, when you run with the Execution Cloud, you do get some extra information attached to each test. And you can see here, if you click on the 3 dots at the end of a test that was run with the Execution Cloud, you can get the Execution Cloud details information, which has a video, the log of the WebDriver commands, as well as a log of any console logs that occurred during the test. So these items are all available for download and review should you want to look into that information a little bit more in depth after a test run.
All right, great. And what if I have a big suite of functional tests today? Can I transfer like that suite and run it against the Execution Cloud? Do I need to use eyes?
No, the Execution Cloud supports both eyes and non-eyes tests, and we have documentation on all of that if you're interested. We ran a test today with using eyes, but it's not a requirement, and you can use any traditional test you'd like to run that don't necessarily need visual AI.
All right, amazing. And then actually, let's see. Oh, yeah, that's a good one. Security, always a hot topic. Do we have? Is there a local tunnel? Can I test my local apps or an app behind a firewall?
Yep. Tunnels are fully supported for local testing. Again, if you're worried about security or something is only hosted on your local environment, we have a tunnel capability, and it's as simple as adding a capability to the Chrome driver capabilities right in here. We also have documentation on that, and if you're interested in that, feel free to come over to the tables after the discussion here, and I can run through an example if needed as well. But it's very simple to set up, not a lot of requirements or overhead.
All right, awesome. Let's see. If anyone else has any questions, feel free to drop them in the Q&A portion. All right, framework support, actually. Yeah, let's talk about framework support. So currently right now, the Execution Cloud supports anything running over WebDriver protocol. So Selenium, WebDriver.io, and a couple of other ones that have shifted to the WebDriver, again, like protocol that has came out of the Selenium project, but it's more than just Selenium. So if you are using a framework that works on that, the Self-Healing Execution Cloud will work today. There are a few frameworks that don't use the WebDriver protocol that we are definitely looking at adding support for in the near future. So if you are a user of Cypress, if you are a user of Playwright, and if you have something that runs kind of dynamically in their own browser, bring it up to us, bring it up to your rep, and we are definitely working on that. So hopefully we'll have that available. All right, I think all right, one more. What happens if the element a test is waiting for just never appears? How would the Execution Cloud handle that scenario? Yeah, so we do have timeout. You are able to set it yourself through a setting, but I believe it is like 60, what is it? It's 2 minutes. It's 240 seconds. So what is that? It's like 3 minutes. 240 seconds we will get hung up on, and then it will close after that 4 minutes. Thanks. So there's definitely, we're not going to make up an element. We're not going to like go click something else if we can find it. There is kind of a fallback, but we will retry a couple times and then slow that down.
Okay.
All right, Patrice, you want to take us out of here? Thank you, everyone, and thank you, Matt, for sure for the demos today.
No problem.